Hey everybody, welcome to Engineering Academy, and in this video I'll be talking about how to extract data from SAP 2000 in order to design a footing. Alright, so before going into the SAP, let me first tell you what are the things that we need for the design of a footing, right? Okay. Alright, so this is our isolated footing, and for designing this footing we'll need the axial load that comes from the column into the footing, and we'll also need a moment in x direction, that is mx, and moment in the y direction, that is my. So we'll need these three things for design of our footing, right? So we'll now learn how we can actually extract these data from the SAP, right? For this purpose, let us open SAP here. So now we are here at z is equal to 8.5 meter level. So what we do, we just go to z is equal to 0 level, right? Okay, so first of all, just click on this icon that shows state display options, and check these the levels option and click on OK, and you'll see the labels, right? So this is 19th joint, and this is 20th joint, and this is 21 joint, and same goes for others as well. And after that, what you do is that you just select all these joints, right? Okay, so these 279 and 80 are for the staircase, and we don't need two joints, right? So after that, click on display and click on show tables, and here you have to click on joint output and click on reactions here, right? So here select load case, and you have to select 1.5 TL plus LL. So that is the load case that we are taking for the design of the foundation. Alright, so click on OK here, and after that click on OK, right? So you can see joint text 13579, so that is for the joint. Here it is 1, and it's 3 is 5, so same goes for 135, so these data are shown for these joints, right? So this is the meaning. And after that you see F1 F2, so you just ignore them. That is basically force in x and y direction, and F3 is the force in the z direction. So this is the axial load that I talked about earlier. So this axial load is represented by F3, and we'll need this F3. So for example, if you have to design the footing for one joint, so what you have to do for axial load, you have to take 248.833 kilonewton, right? So similarly, so we got MUX and MX and MY, that is moment in x and y direction. So this is M1, that is the moment in x direction, and M2, that is the moment in y direction. So you have to take these two values as well. Alright, so now comes the question, how to design the mat foundation. Alright, so the answer is just simple, and so let us consider this footing as an example, and you can see they are isolated footings, right? So let the total area of the isolated footing be A1. So that is not the individual footing, so this is the total area, sum area of the individual footings, that is, let it be A1, right? So now what we do is that we replace the isolated footing with the mat foundation like this, or mat or raft, just like this. So this is just an example, right? So this is our raft, right? So let the area of this raft be A2. So if A1 is more than 50% of A2, that is the area, sum of the area of the individual footings is greater than 50% of the raft foundation, then we go for the raft or the mat foundation, and we design the mat foundation using the procedures that we have learned in the RCC. Alright guys, so this is how you extract data for the design of the foundation. And alright, so this is F3, M1, M2, so this is all what you need. Okay, hope this video was helpful, and thank you for watching. Take care.